Hello. Today we are starting a new unit on kinetics and equilibrium of chemical reactions. Kinetics, first of all, let's define those words. Well, first of all, kinetics. Kinetics is the branch of chemistry that concerned with the speed of chemical reactions, and also it looks into what factors and why those factors affect the speed of reactions. What can speed up the chemical reaction, what can slow down chemical reaction, and most importantly, why those factors are in charge of the speed of chemical reactions. So to discuss those terms, to try try to come up with some explanations for the speed of chemical reactions, long time ago, people formed a collision theory. Collision theory is a sort of a set of conditions that are necessary for chemical reactions to occur. For a chemical reaction even to occur, there are certain conditions that must be met. For example, one of them, the first one, is the fact that the particles for a chemical reaction that must meet. If we have two reactants that are never ever meet each other, never collide into each other, then there would be no chemical reaction whatsoever. So the particles of reactants must collide. If they collide, then that collision has a possibility to proceed and form a new chemical bond. But it is very, very important to understand that not every collision leads to a reaction. There are certain conditions apart from the collision itself that must be met for a chemical reaction to occur. So another thing that apart from the collision that must be happening is that the collision between the reactants must happen at particular orientation, specific way. Sometimes we might have a collision between the reactants, but if the molecules during the reaction were angled not in the perfect way, not in the right way, that collision will not break the existing bonds of the reactants, and new bonds, the product, will not be formed as a result of it. So we need so far two things. We need a collision between the reactants, and we need that collision to be done at a specific orientation that is favorable for the existing bonds to be broken and new bonds to be formed. Okay, and the last condition that is also need to be met is that the collision would occur at the right amount of energy. Sometimes we might have a collision, and it's even might be a collision at the right orientation, but it is such a gentle collision. It is so nice touch between the molecule that actually energy of that collision is not big enough to break the bonds of the reactants and eventually lead to the formation of the product. So we need three things to occur. We need a collision. We need the collision with the right orientation of the molecules during that collision. And also during that collision should be happening at the high enough energy for the reactants to abandon their initial properties, to break their chemical original bonds, and eventually lead to the formation of the new bonds of the products. So, with this collision theory in mind, let's consider what factors might possibly affect the speed of reactions. Well, here is a list of factors that have been observed to affect chemical reactions. That would be nature of reactants, concentration, surface area, temperature, pressure, and the presence of the catalyst. Well, clearly, just having the list of things that affect chemical reactions is not enough. We actually need to look deeper. We need to understand why those factors do have ability to speed up or slow down the reaction rates. So let's talk about them a little bit deeper. Well, first of all, the nature of reactants. Reactants are not created equal. Some of them have stronger chemical bonds and some of them have weaker chemical bonds. Those with their weaker chemical bonds, having them initially, will break more easily and will be more readily forming the product. Sometimes we can be comparing covalent and ionic compounds. Many covalent compounds, especially organic compounds, have such a sheer big number of chemical bonds in them that it will take quite a bit of energy to break all of them and form a new compound. So, just a sheer nature of reactants can play an important role in the reactions being slow or fast. And covalent compounds tend to react a little bit more slower compared to ionic compounds. Now, let's talk about concentration. Most chemical reactions will go faster if concentration of reactants is increased. And if you think about it in terms of collision theory, you will see that it's a little bit self explanatory. When we increase the concentration of reactants, we pretty much increase the number of particles. If we have more particles, there would be just by sheer increase in the number of particles, there will be increase in the number of collisions. And since we have more collisions, more of them will be proceeding to the formation of the product, and forming the formation of the product will speed up the reaction. So if you look at this, over here I have reactants and products, but the concentration is low. Those particles will probably collide into each other, but the number of collisions will be relatively low. If I increase the concentration of my reactants, I will have more collision out of just sheer number of particles. They will form more collisions, and out of more collisions would be probably higher number of them will be able to proceed to formation of the product, thus increasing the speed of the reaction. Now, let's talk about surface area. The increase in the surface area usually leads to increase in the rate of the reaction, because whenever we are increasing the surface area, we pretty much creating the conditions when the particles can form, can be colliding into each other much more frequently. So, for example, the crumbled substances will react more rapidly than big lumps of the same space. You've seen many movies probably about alchemists, and the ancient alchemists usually shown as the bearded men that are laboriously grinding something in the grinding balls like this. It's called mortar. And the reason that they are grinding their chemicals is that they eventually want to see the reaction occurring much faster. They are grinding their solid reactants to increase the surface area at which this particular reactant will react with another substance. Another example of this idea is right over here. Look, I have big lump of magnesium, and right now this surface area right here is the only place where water and acid can access magnesium. If I grind or if I break my magnesium into smaller pieces, there will be significantly more points at which magnesium will be accessible for a chemical reaction. Thus, increasing the surface area usually speeds up the chemical reactions altogether. Our number 4 factor is temperature. And the higher is the temperature, the faster the substances are reacting. Well, by now you all know that the temperature represents the amount of kinetic energy in the molecules, meaning that in the substances with the higher temperatures, we have molecules moving faster. And this sheer increase in speed increases the number of collisions. Our fast moving molecules will be colliding much more frequently because they are moving so much and so fast. That alone will increase the speed of the reaction. More collisions, faster reaction. But on top of that, with temperature, we also know that those molecules moving at a higher velocity, they have high amount of kinetic energy. It means when they collide into each other, they collide with the high amount of energy. So temperature works on two things altogether. It increases the number of collisions just by out of entire increase in speed of collisions. But on top of that, those collisions are happening with the high amount of energy in the particles. Thus, more of those collisions will have enough energy to proceed into the formation of the products. Pressure. The pressure also affects the speed of reactions, but it has very little effect or almost no effect on solids and liquids, but it does big deal for gases. Because if we apply pressure on gases, we can change their volume. We can force gases to occupy less space. We can decrease the gaps between the water gas molecules and thus forcing them closer together. So it is pretty much equivalent of increasing the concentration of our reactants. This is pretty much what we're achieving whenever we're squeezing down the gas. We increase the concentration of our reactants, and as a result of it, there will be more collisions and more out of sheer number of collisions, there will be many of them that will proceed into the formation of the product. Thus, we will increase the speed of the reaction. And the last one would be the effect of the catalyst. Catalyst is a substance that increases the rate of reaction by decreasing the activation energy of the reaction. I want you to remember this particular term, but because we will be coming back to it and we will discuss it. But pretty much what it refers to. In any reaction that we might be talking about, for those reactants to form some new compounds, they first need to break down their existing compound, the existing bond of the reactants. The reactants itself, by themselves, are stable, probably stable substances with chemical bonds in them. To force those substances to break down their chemical bonds and rearrange themselves into the new reaction, we first need to spend some energy on breaking those bonds. So, what catalysts do, they provide the conditions in which this initial activation energy that goes into breaking the original bonds of the reactants, is decreased. It can be done by arranging the molecules to be in a specific orientation towards each other, or maybe providing alternative route for the chemical reaction. But as a result of it, we have to spend less energy on breaking the bonds of the reactants, and the chemical reaction goes faster as it takes a little energy to initiate the precision towards the products as a result of it. Okay, so we will stop right here for today, at least with the factors affecting rate of reactions. But I want you to know this list, but not only know them by name, but understand deeply how those factors affect the why and how those factors affect the speed of reactions.